interface review came out as interview, I think. Because I don't feel like I had a good day on Monday. All right, I don't feel like I did a great job explaining interfaces. So let's sort of rewind and talk about them. So we'll talk about those for a while. I'll answer any questions that you have. Our two mini topics are dates and boxing/unboxing. And then our next big topic is try-catches, which we probably won't get to today. We might just have enough time to begin it. Anyhow, interfaces. Can someone say one true statement about interfaces? They're a contract. I like that description. What does that mean to say that they're a contract? Okay. That anything that implements that interface has to define a concrete that is not abstract version of every method defined in the interface. All right? That's absolutely correct. The only thing I didn't like about your description is you mentioned attributes. Interfaces actually don't have any attributes. Interfaces are all methods. Does anyone care to add to that description? Maybe give their own description of interfaces.
The way I understood it is there are basically methods that can be used across different kinds of objects.
Okay.
So it's not necessarily limited, like a superclass type deal where only the children of that class can use those methods, but it can use across different kinds.
That is very true as well. It differs from inheritance in a couple of significant ways. Inheritance you think of when you have a sort of a strong is a relationship or is a kind of relationship. A motorcycle is a vehicle. A bicycle is a vehicle. An automobile is a vehicle. Interfaces are typically for less important is relationships. For example, a bird is an animal, but a bird's also a thing with feathers. A bird's a thing with feet. A bird is something that eats worms, all right? And so on down the line. You can define multiple interfaces, or rather a class can implement multiple interfaces, where a class can only be a class can only have one superclass directly above it. But a class can have multiple interfaces that it implements. Interfaces are sort of Java's solution to multiple inheritance, because you can't have multiple inheritance in Java, but you can implement multiple interfaces. And what that means then when you implement an interface is, as we said before, that you will have those methods defined. All right? So let's look at the example we had last time. We had has seats. And our interface for have seats, we've defined two methods. And they are abstract methods. If it's an interface, you don't need to bother saying it's an abstract method. It's just by implication it's an abstract method. And with any abstract method, all you have charted out is the return value, the name, and the arguments. That is the signature of it. So anything that we define as implementing the interface has seats has to have these two methods in it. Get how many seats and fits. Whereas fits, you give an argument and you return if that number of people would fit in that particular entity. So we created two of these, an auditorium and a room. So both of these we stated implements the has seats interface, which means that both of these need to have get how many seats, because that's one of the methods implemented, and one of the methods described in the interface, and fits. So the room class has defined a type of room, and the way that we calculate the size of the room is, if it's an office, it has this many seats. If it's a classroom, it has this many seats. If it's a lab, it has this many seats. If it is a lecture hall, it has this many seats. And the way that we implement the fits is first we look to see how many seats it is, and then we return true if it fits. Otherwise, we return false. Whereas an auditorium, we simply have a capacity defined, and we return the capacity for that. We can then treat this in a polymorphic way in our unit test by creating an array list, and we can add to the array list anything that implements that interface, and we can ask each of them, gee, how many seats do you have? Get how many seats. We can do that because we know that anything that's in here implements that interface. Because it implements that interface, that's another way of saying it's going to have all the functions that exist in the interface, in the interface of has seats, and therefore we can call any of those methods. And we know that it has to have them because we're only putting in the array list things that implements the interface has seats. Questions about that?
In order to do the array list, would it have to be just upon an interface, or could you also do an array list with an inheritance?
You could do an array list with an inheritance as well. Okay. All right. In other words, an interface and subclasses and inheritance are similar. The difference is with inheritance, you actually get the chance to reuse code. You can define code on a superclass level that gets executed for the subclass. So you don't have to redefine the code on the subclass. An interface, you don't get any reuse of code. You simply get the ability to treat it polymorphically. And this is an example of something that's treated polymorphically. We give two different objects to that array list, and the number of seats is calculated two totally different ways. One is based on an attribute, one is based on the type of room it is. Questions about this? We'll see this going forward a lot. Interfaces are going to become important when we start talking about user interfaces, interestingly enough, even though the two names really don't have anything to do with each other. They're both called, other than both being called interfaces. The example that you gave, or the example that you have to do as an assignment, involves having an outlet and various devices that have plugs. And some of the devices have plugs where you say this has this type of plug. And outlets also have a type of plug. Others, for a laptop, for example, depends what country the laptop was sold in. If it's sold in this country, it has this kind of plug. If it's sold in that country, it has that kind of plug. And you have to be able to take anything that implements the interface of has a plug, all right, and see if it will fit in a given outlet. All right? So that's the way that we're using interfaces. A key thing about interfaces, again, is it can be across the inheritance hierarchy, whereas inheritance strictly goes up and down between subclasses and superclasses. An interface can be implemented all over the place, all right? And again, it's for the less important qualities, less important things that they have in common. All right? Okay, I hope that clarifies it. If that doesn't clarify it, when you do the lab, that should clarify it. And I hope it does for you. All right, next up, dates. For one of your assignments, and again, I apologize again for being delayed on the grading of your work. I'm making progress, but every time I make progress, something comes up that knocks me behind. So I try to be understanding with students in their late assignments because I sometimes have difficulty getting things done on time. This is in the week 6 module, and this talks about using dates. So the main class dealing with dates that we have should be set type, not set capacity. I've just created using a bunch of date objects and different things that you can do with the date object. First of all, these dates are using the local date class. A local date class is where we're not concerned about the time zone. So all of our dates and times are considered to be whatever our current time zone is. So there are other date classes that depend on the time zone that you're in and have a time zone associated with them. But of course, as you can imagine, those are a little more complicated. So if I say what's the difference between noon here and 1 o'clock here, that's 1 hour, right? But if I compared what's the difference between noon in Chicago and noon in New York, they're the same. I'm sorry, noon in Chicago and 1 p.m. in New York, that's actually the same time. There's actually 0 hours difference. So the local date is used for comparing within a time zone. Hence the term local. All dates and times are assumed to be local. All right. So that's useful, like if you're talking about a library, because a library, you check it out and you're returning it at the same place. So there's no question of like what time zone it's in. It's all the one time zone. So that's what a local date is. All right. And I've imported some of these things here. And the first thing I can do is I can create a local date object that has the current date in it. And I do that by saying local date, the name of my object, equals local date dot now. And I can print that out. A second way that I can create the local date is by saying local date date equals local date of, and supply 3 numbers, a year, a month, and a date. The third way that I can do it is I can specify a date of 2016, the month of July, and the date of the 4th. So I can use month literals. There is month dot, and I can use January, February, March, April, May to designate the month instead of the month number. Now here's an interesting thing. Notice that I set this to the 4th of July on 2016. And I set this as the 4th of July on 2016 also. I just did a different way. Let's compile it though and see if those two things are really equal. This brings up a point that is worth reinforcing. All right, I compile this. Then I'm going to run it. And notice what I get. Current date is 2018-10-10. That's correct, right? That's the current date. Here's where I create the 4th of July one way. Here's where I create the 4th of July another way. And then this line, though, says that the two dates aren't equal. So I created the current date and used that to output it. So it shows me the date. I created date 2 and date 3, both of which are the 4th of July. And if I look to see what it outputs, it outputted the 4th of July for both of them. So presumably that's the same date. However, when I look and ask, are they equal, I get the message that says the dates are not equal. What is going on? Why does it tell me those dates are not equal? Yes? It's comparing two objects. What does it mean when we compare two objects? Exactly. It's comparing the pointers. It's comparing their location in memory, all right, of one to the other. So getting back to what I've drawn up here a bunch of times before. Date 2 creates a date object. Somewhere in the heap, it creates a date object. And we set the date to be the 4th of July, 2016. So let's say that's memory location 1000. D2 then will have a value of 1000. I create D3 as a new object. It gets put somewhere else in memory. And it has the same date. But it's in a different memory location because it's its own object. I create two objects, D2 and D3. Both of them have the date of 7/4/2016. One is created, the first one's created in memory location 1000, the other one's created in memory location 3000. Because these variables are object reference variables, when I do the comparison, I'm comparing the value of the pointer. And therefore, these two things point to different objects. And therefore, it's going to tell me that the things are not equal. All right? You have to be aware of that for any kind of object that you do. All right? Any object reference that you do has a potential of having this sort of problem in it. Because when you say two objects are equal, you're actually saying, do they point to the same object? Not is their value equal to the value of the other object. Do they actually literally point to the same object? Not are they equivalent objects, I guess we'll say. That's why we have a method on the date object and on the string object as well that says equals. And so we call the method on the local date, does date2 equal date3? And in that case, it doesn't look at what object you're pointing at. It looks at the actual value. In other words, the equal function will return true, that they're equal, if the month, day, and year all match. So that's the difference between this way of looking at the object and saying that they're equal and this way. This is actually asking, are they the same object? Are they pointing to the same object in memory? This looks and says, is the value of the date stored in these objects the same? Is the month, day, and year the same? You actually have the exact same thing in strings, right? In the pizza example, I say something like, if size equals small. So I do something like that. Why? Because strings are their own objects. And therefore, if I'm doing a comparison, I don't want to say, does object 1 equal object 2? All right? I instead want to compare to see if their value is equal, and that's what this does for a string value. Same thing applies, by the way, why I can't say is date 1 greater than date 2. Is date 2 greater than date 3? Is date 3 less than date 4, or whatever? Because with dates, you're always dealing with an object, and any comparison of that object will be a comparison of the pointers, not the date contained in the object. I can also do date arithmetic. I can take and say date 4 equals date 1 plus days and give the number of days that will add to it. This would be useful in determining like when something is due, well, library materials. If you checked it out today and you have it for 7 days, you'd do the checkout date plus day 7 would give you the date that it was due. Notice in this case, 28 days from today is November 7th, which I guess would have to look at a calendar, but I'm pretty trusting that that's the right amount, the right number of days. I can ask if it's after a date. So is date 4 after date 1? And of course it is. So it will return true. Yes, it is after. I could say how many days there are between, and give it 2 dates. So how many days are there between date 1 and date 4? And as you imagine, I get 28, right? Which is what I did, what I added on initially. Finally, I can say, how many days is it from this date until this date? I'm going to switch this around and say date 4 and date 1. And it gives us 28 or negative 28. Gives us 28 if we go from the earlier date until the later date. It gives us negative 28 if we go from the later date until the earlier date. There's other functions as well, but I think these are enough to get you through the library example. Because what do you want to know in the library example? Well, you have the date that something was checked out, and I want to initialize that date. So how do I initialize that date? Well, I can either take the date of now, if I assume it's checked out now, or I can set the date to some previous value that I want to set it. Notice how this doesn't do a constructor. This actually uses other methods. It uses the now method and uses the of method to create it. Constructors aren't the only way that you can create items. Some methods, or rather some classes, give you static methods which allow you to create an object other ways. And the of and the now are 2 examples of static methods that exist on the local date that allow us to create objects of that type with a certain value.
I have a question.
Yeah.
With the classes that you import into, where do they come from? Where are they actually stored? Are they in the Java library itself, or is it from the internet somewhere?
They're not from the internet. They are from when you install it. Let me see if we can find it. They are actually, when you install the JDK, they get installed as part of that. They're part of the Java framework, and it would be in these jar files, I would believe.
Is there a list of all the different libraries that are available somewhere to us, or?
Yes.
Maybe you could do it right now.
Yeah. The key to this, these are contained in Java docs. So you look for the Java API, and it shows us all the things that are included in the Java API. There's Java I/O, and so on. Or if you look like in Oracle documentation, This is looking at a lot of other products by Oracle. Here we go. All the classes, all the packages that exist, and so on. Yeah, a lot of stuff. It's a bit of a skill to read these, so it's good to practice it. A lot of times, like if you're looking for like a method, you have to remember that it's not going to show all the methods that come from the superclass, but it will tell you what the superclass is, so you can look for a method on it, on a particular class, or look on the superclass to see the methods. Did I see another hand up? Yes.
Is it possible to create an empty object and then values later on?
Sure. You would do that by saying something like LocalDate D equals new LocalDate. I think, provided there's a constructor that accepts no argument. Let's go and look that up in Java docs. Okay. Here's the interfaces that this guy implements. So it promises to have these methods. Extends object. That means that there's no other superclass. Object is sort of on the top of the inheritance chain. Everything extends object. It's in the package Java time. And if we look here, here's a list of methods. Is there a list of constructors? I don't think there are any constructors, which means that the compiler will give us a default constructor. So we should be able to say LocalDate D equals new LocalDate. Let's see what happens if we do that and try to print it out. Oh, no, I guess it requires, I guess there is a constructor that requires 3 arguments. So I guess to answer your question, it doesn't seem like there is a way of creating a empty date.
I just do LocalDate D colon, and it seems to give me, and then I set it to what I want to using those other parameters.
Well, LocalDate D colon, that's not, strictly speaking, giving you an empty date. That's not creating, if I just do this, that's creating a pointer that doesn't point to any object. So there is no date object. It's a little confusing. There's a difference between null and an empty object. All right. Null means that it points to nothing. An empty object would mean that it points to an object that doesn't have any value set. All right. So to answer your question, I don't believe that that's possible. You could possibly read the documentation. Maybe I missed something in there.
Well, I know I used it in the library, not in the library, but in the student, where we were calculating tuition.
Okay.
And I used LocalDate, colon. And then when I called it, of course, I did create an instance of it, and everything seemed to have worked correctly.
Right, but again, you didn't create an empty object. You had a null object pointer. And that's different. Pointing to no object is different than a pointer pointing to a object that is empty or an object that has no value or has blank values.
Okay.
All right. Questions on dates? All right. Last thing I want to cover today, because we'll leave try catch for later, is boxing and unboxing. Okay, we talked about primitives and object references. What's the difference between a primitive and an object reference? Right, exactly. A primitive like int, the variable contains the value. So if I said int I equals 253, there's a variable called I that has a value in binary of 253. Takes up however much space integers take up in Java. If I do something like this, pizza P equals new pizza, I have a variable pointing to an object in the heap. That's all the information about a pizza. And this will be the location. And with an object reference, the variable holds a pointer to where the actual object lives in the heap. Whereas with a primitive, the variable contains the value. All right? Doesn't contain a pointer to anything. It's just what you see is what you get. It contains a value. Now, sometimes you need essentially object versions of primitives. Classic example is with an array list. All right? An array list only holds object references. An array list does not hold primitives. All right? So I cannot do this in my code. Can't do that because this is not an object reference. This is a primitive. So if I tried to do it, I get an error, unexpected type. You need an object reference, and I'm trying to give an int here. So I can't create an array list because I need an object reference there. I can't do it with a primitive. There are sort of wrapper classes. Wrapper, W-R-A-P-P-E-R. They wrap around the primitives. Well, I just didn't want you to think like, you know, JZ new equals new JZ or something like that, and it starts wrapping that way. All right? These classes go around the primitives and sort of make an object version of the primitives. And they all start with a capital letter. That's how you can tell the difference. So the object version of an integer is an int, or the object version of an int is integer. So if I wanted to store a list of integers, I couldn't say I want an array list of ints. I could say I want an array list of integers because integer is an object reference version of an int. And this I would be able to compile. Oh. Forgot to put my import in here. All right, so that I can do where ints I can't. Okay, all well and good. How do you use these wrapper classes? And here's the good news, and here's what's called boxing and unboxing, is I can sort of treat integers and ints seamlessly and work them together. So if I do this, int x equals 1, int y equals 5, integer z equals 3, integer y. I can mix and match ints and integers for the most part without any consequence. So I could say y equals x plus z. So x is an int, y is an integer, and z is an integer. And yet, the compiler has no problem with this statement, because the compiler boxes and unboxes. Unboxes where it takes an integer and treats it like an int. So in this case, it's going to treat z, which has a value of 3, like an int. And it's going to add that to x. It's going to get a value of 4. Boxing is the opposite. I have 4 over here. I'm going to take that 4 and store it in an integer object called y. All right? Normally, when you have to set a property in an object, you'd have to say y.setValue equals something. Here, you don't need any sets. You can treat it just as though it's an integer, just as though it's an int, and the compiler takes care of any boxing and unboxing. That is, it will treat an integer like it's an int and an int like it's an integer. You had a question?
Yes, so in this case, both the value of y, whether you are referring to int y or integer y.
Oh, I have two y's. My mistake. Let's call this q.
Okay. I didn't know if it was set both
No,
of them before.
I can't have two variables with the same name.
Okay.
So in this case, if I had q, it would take the value of x, which is an int with a value of 1, z, which is 3. So I'm going to treat 3 like an int, even though it's an integer. I'm going to add it up, and I'm going to stuff the result in an int. I'm sorry, in an integer. And then I could say system.out.println q equals it tells me q equals 4. So in a nutshell, that's what boxing and unboxing is. If you need an object version of something to add it to an array list, I can then go and say list.add q. And I can do that because q holds integers, and this is an integer.
Could you say list add x, or that would not work?
I have a feeling it will work. Let's find out. That's a good question. It does work. Essentially, the compiler converts ints to integers and integers to ints as needed. So if it needs it to be a primitive, it makes it a primitive. And that process is called unboxing. Boxing, if it needs an object version of a primitive, it makes it into an object. And that's exactly what it did. So in this case, it's an example of boxing, right? Because you gave it a primitive, this add needs an object. So it boxed it up into a nice little integer package, and it added the integer to that array list. This is actually a version of boxing, right? Because normally we don't say integer z equals 3, right? Normally we don't say like pizza p equals some value. We say equals new pizza. But here we're just saying it's going to equal this int. And this int then gets converted and boxed in an integer box. All right? Actually, strings do this a lot. Strings are actually objects. But when we say string s equals, it goes and takes that string and creates a string object from it. All right? So this isn't really boxing, but sort of the idea is the same. Whereas string is a object reference, but we can sort of treat it like a primitive. These are some of the reasons why people say Java is not a pure object-oriented language. First of all, it has primitives in it, and secondly, the objects in it sometimes let you sort of treat them like primitives. This exists for every other primitive that there is in Java. So if we look at the wrapper classes in Java, each Java primitive has a corresponding wrapper. Boolean with a lowercase b corresponds to Boolean. Byte with a lowercase b corresponds to byte with a capital B. They all are simply the same name, except char and int get the full word character and integer. They're in Java lang, so you don't need to import them. and they describe auto boxing and unboxing. This pretty much the example that I just gave, or over here. Okay. Questions? All right, those were our sort of 3 mini topics for today. Next week, on Monday, we will start with try-catch blocks. All right, see you in lab.